Okay, welcome to Chapter 40 in the Practices book. Actually, we're going to start on Chapter 39, so that's a lie. So on page 693, we start talking about the whole concept of a namespace. So what the heck is a namespace? Well, let's just say you're a developer and you're developing an apartment complex. Okay, so you got, I don't know, half a dozen buildings. Each building is exactly the same. They're all 3 stories high, and there's an apartment, 4 apartments in each floor. So there's 4 here and 4 here and 4 here. So there's 12 apartments per building. And so the foreman of the construction company comes up and says, "Hey, how are you going to number these things?" And you go, "Well, I don't know. How about a letter for the building? And we'll use a 3-digit number. The first digit will be like the floor. So if you're on the 2nd floor, and if it was unit 2, so that would be Building A, 202. So that's a namespace. It's just a set of rules that you put together to make sure that when you're talking about something, you know exactly what it is you're talking about. The most important part is there's no duplicates. There's no way that I could have, apartment A104 and have that mean something completely different. It's got to be a Building A, 1st floor, 4th unit, and it's consistent. That's the whole point of a naming convention. Okay, so most of the time, naming conventions are in some sort of a database, right? It could be PC names or user names or email addresses, those kinds of things, right? And as you know, there's no way that 2 PCs inside the same company could have the same name. And there's no way that 2 users inside the same company could have the same name. And there's no way that 2 email addresses anywhere on the planet could be the same. Right? Okay, that's the whole point. And so there's some examples that we're going to go through in Chapter 40. The domain name system, DNS. Hopefully you guys have taken a networking course. You know what I'm talking about here. DHCP, Dynamic Host Control Protocol. LDAP, lightweight. Okay, good. All right, so let's just talk about the rules. So the rules basically are namespaces. Need policies. You're going to have some sort of consistent naming rule, right? It's going to have to handle how long these things are going to exist and locality and exposure. The need for procedure for adding, changing, and deleting one. You need to be able to do that. And then some sort of centralized management. If you're doling out unique names in the world, well, then clearly you can't go to 2 different people to get that done. You need to go to one central location. So like the DNS system has a very strict hierarchy. I mean, you have to go to a registration authority and say, "Hey, I'd like to register my name of, bestkumquats.com." And they're going to say, "Hang on a second. No, that's already been taken. You need to come up with something else." So yeah, that's the way that works. Okay, so they start talking about, as an example, a machine naming rule. So let's say, taking this into consideration, just naming PCs or servers. So there's a thematic approach. Thematic basically means, you could come up with cool names, Disney characters or, planets. The one I had when I was working with the folks at the University of Illinois at Urbana-Champaign, they use mythology from Egypt. So Osiris was the machine that I always played with. Okay. Functional. So the machine might be admin desk or, engineer number 2, that kind of stuff. A descriptive could be, Dell model 123. Descriptive works really well when you're talking about printers. Color printer number, blah, 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 such and such plotter, brand names or descriptions of what it is. So it works really good when it comes to printers. Some sort of formulaic thing, PC 102. And then some sort of a formula to follow. So the Army came up with a goofy formula for naming things. Here's just an example of one of their coding systems. So if it was a domain controller, an application server, and then these other things about, you could kind of file server and blah, 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 blah. So now, to tell you the truth, there's probably a little bit of problem with this. Let's say, for example, that I wanted to, mess with the domain controller at Fort Hood. I know it's going to be Hood A1 NEC 001. So having a consistent formula works really good if you're trying to figure things out. But on the other hand, you're kind of sort of giving an awful lot of information away here. I mean, if it was named after a Disney character, I wouldn't know which one was the domain controller or not. Okay, just saying. So there's a little bit of problem with this. A hybrid, of course, it's a combination of the techniques, right? And then no method at all? Oh, man, don't do that. I mean, clearly, when somebody comes up and says, I'm on computer number, asset tag A, B, 1, 2, 3, 4, that provides me no information whatsoever. I need to know where are you, what floor you are, what room you're in. I need a lot more than that. And so, what happens if you have conflicts? I just told you that the whole point is to not have conflicts. Well, that works great, except for when you merge with another company. And let's say there's a Jane Doe in the first company and a Jane Doe in the second company. And what happens when you merge the two together and they both happen to have the same email address? Somebody's going to have to change theirs. And is that going to be a problem? To tell you honest to God truth, if that really happens in real life, you need to change them both. Don't just go, oh, well, the new person gets a different one and the old person stays the old. No, don't do that. Don't do that. Basically, what you need to do is to keep the old ones the old one as it is, and then convert them both. Add a 1 or a 2 to each one of them, because that way somebody's going to mess up and send it to the wrong address, and you're not going to be able to figure it out. So just saying, when it comes time to merge, you're probably going to have to come up with, don't just leave one the same and change the other, because that'll be a disaster. And so, PC and server names, right? You can't have the same thing. Usernames, yeah, you're going to have some problems with that. Email, of course. So let's talk about the life cycle on page 699. Let's say that Bob Jones left the company, and so that name is now available. So another guy who's not related at all, but happens to be called Bob Jones, comes to work a year later. Are you going to recycle that thing and give him Bob Jones's name? Well, for a user account, you actually could, because the user accounts there's actually a unique number behind the scenes. Okay, it's not the letters. Okay, right. But for an email address, holy moly! The original Bob Jones gave out a business card 10 years ago, and so you're going to be getting this email from some place, hey Bob, I have long time no see, can you help me with this project? And you're going to go, what the heck are they talking about? So yeah, that's a problem. Basically, you delete things as soon as they happen, right? As soon as a person leaves, you delete their user account. But what about their email account? Do you want to have a redirector that says Bob no longer works here? Or maybe have it, forward to his supervisor or something? And then reuse? No, I'm sorry. Once Bob Jones is done, don't ever reuse that name ever again. I'm just sorry. That's just not the way to do it. Okay, I'm going to skip a bunch and get down to page 708 where they start talking about the Federated Identity. So, Microsoft has been trying to do this. It's like, let's just have a Microsoft account. And by the way, Microsoft account doesn't mean a Microsoft-based email account. You could have bobjones@gmail.com and use that as your Microsoft account. It's a Google email address. That's not what they're talking about. What they're talking about is when you sign in to these services, you could have one set of sign-in that works for everything. It works for your Facebook. It works for your, your school work. It works for, everything. Just have one single set that everyone uses, a single sign-on thing. And that even makes it, more better when it comes to, do I know which person I'm talking to? Because I'm only using one account to talk to everything. Anyway, Microsoft's been doing this for quite some time, or trying to. Like when you install Windows 11 now, you have to go through quite an ordeal if you do not want to use an MSA. It's an awful lot of stuff you have to do that. Anyway, single sign-on is good. I don't want, when I go to, the university website and I go to Canvas and I go to a thing called Warrior Web, I have one account that takes care of all that for me. Okay, so I like the single sign-on. Okay, good. Okay, so now we're actually going to step into chapter 40 on page 711. Okay, so name services. We had to get through a little bit of chapter 39 for this to make sense. So The whole idea is consistency. This is one of the things they talk about. There should be just one policy that determines how things work. Okay, not a consistent way of applying the naming rule. Don't say, well, Bob's computer is different, we're not going to do it that. No, be consistent. Authority. If there's multiple ones, somebody has to be the tiebreaker. Somebody has to say, I'm sorry, that's not going to work. We're going to have to swap you out. Hopefully swap both out. Capacity and scaling. If this thing is like a database, is it strong enough to be able to handle all the users? If it's text file or something? I mean, if it's just naming computers, there's probably not anything other than some piece of paper that says, here's the way you name computers, right? That's no big deal. But who's keeping track of what the current names are? So if you typed in one, it should come back immediately and go, oops, that one's already taken, right? So it has to be somehow like in a database. And then reliability. There's an awful lot of dependencies on namespaces. Let's just talk about the DNS namespace for just a minute. If for some reason your DNS server that you're using right this very second goes down, how long would it take you to figure out that something was wrong? Probably almost immediately. As soon as you clicked on some web page and it came back and went, huh? You'd go, whoa, what's going on? Is my internet down? Yeah. So these things really, really have to be reliable. Lots of dependencies, so we're really going to have an awful lot of duplication, right? Okay, good. Okay, so the example they start talking about on page 714 is DNS, so the domain naming system. So let's just talk about what DNS is all about, just to make sure. I mean, I know you've already taken a networking course, but if I want to talk to a server in my own company, or to an email address at some other company, or to a printer that's down the hall, I need to be able to type in a machine name and have somebody go in there and translate that to an IP address. That's what DNS does. So there's two components to this. There's a client-side component that gets installed, and we've kind of seen this before. I'm going to bring up the guy here for network connections. We've kind of sort of done this before. When I go to Ethernet, and I'm going to go and say, adapter, I go grab my guy, and I go bring up properties, and finally get down to the part where we got this guy, and I go to properties, blah, 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 blah. Oh, okay. So this is what kind of sort of we're talking about. Most of the time, there's two DNS servers, because it's that important that you want to have two. So this is how I get my data on how to look up, www.google.com. It goes here and pulls this information. Okay. The server side is a little bit more complex. Now, we set up a DNS server when we did our domain controller, but there was nothing to configure because we're a special environment, and all we told it is, look at the things that are inside your network and remember them, okay? And then if you don't know the answer, go ask someone else. That's it. That's all we did. And that was automatically set up for us. We didn't actually have to type anything to make that happen. Okay. So there's a really cool thing about how DNS servers actually keep each other up to date, because when something changes, particularly if it's a router change, like I've moved from one hosting company for my website to another hosting company. And so I want to point, the DNS server used to point to the old one, but now I want it to point to the new one. So I would go to the DNS authority and say, hey, I've made some changes here, and it would replicate to the others. Now, to tell you the truth, it takes about a day for replication to go worldwide. Okay, it's fast, it's reliable, but not super fast. And so they use this thing called an anycast. I know I'm kind of getting into the weeds here, but an anycast is kind of sort of like a broadcast, except a broadcast sends to everyone, right? This sends to a list. It's like a subscription list. It's like, here's all of my neighboring DNS guys, and so I just make a list of them, and then I broadcast to them. And so broadcasting these guys kind of speeds things up a bit. It doesn't take very long, for example, for a particular DNS server to realize that something has changed. And so it only replicates the changes, not the whole DNS table all over again. Hey, we're coming up on the 15-minute mark. You guys know how this works.